Hey everybody, today we're doing a harder example of integration by parts. We're going to look at this problem, the integral of x squared minus 3x plus 5 times cosine of 2x. This is a good candidate for integration by parts for at least 3 reasons. First of all, it's a product, but not the sort where u substitution will help you. Second of all, one of those factors can be integrated, cosine of 2x, and the other one gets simpler when you differentiate it, x squared minus 3x plus 5. That degree 2 polynomial, when I differentiate it, will become a degree 1 polynomial. Finally, even if you know lots of techniques of integration, this is the only one that really helps you. Let's remember our formula for integration by parts. Integral of u dv equals uv minus the integral of v du. We choose u to be the factor that gets simpler when it's differentiated, and we set dv equal to everything else. So u equals x squared minus 3x plus 5, dv equals cosine 2x dx. Differentiate u, solve for du, anti-differentiate dv, and then take those ingredients and put them together according to the integration by parts formula to get this. We've made progress. The integral that we have there on the right is now a degree 1 polynomial. It's linear instead of quadratic as in the original problem. But we're not done yet. So let's just look at the integral of 2x minus 3 times sine 2x dx. Let's get that done, and when we're finished with that, we'll go back and put all the pieces together. U equals 2x minus 3, dv equals sine 2x dx. By the way, these are different u's and v's as before. Technically, I should probably call them u2 and v2 or something like that. But I don't think there's really any possibility of confusion here. Differentiating u, solving for du equals 2 dx. Anti-differentiating dv, we get v equals negative 1/2 cosine 2x. By the way, I'm leaving out the plus c when I'm doing these calculations. We'll put in the constant of integration at the very end to make sure we have the most general antiderivative. That's always how we do it in integration by parts. So the integral of 2x minus 3 sine 2x dx is going to be uv minus integral of v du, so negative 1/2 2x minus 3 cosine 2x, plus the integral of cosine 2x dx. That last integral is direct, so let's go ahead and do that. And I'll also rearrange the negative 1/2 times 2x minus 3 cosine 2x just a tiny little bit. Okay, so now we've got all the pieces we need. Here's the result of our first integration by parts. Here's the result of our second integration by parts. So all I really need to do is to take the second one, take the right-hand side of that second equality, and plug it in for the integral I have up top. There it is. The last thing I'm going to do to complete this problem is to distribute the 1/2 through, neaten things up a little bit, and make sure I have my plus c. There's the answer. 2x squared minus 6x plus 9 all over 4, sine of 2x, plus 2x minus 3 over 4, cosine of 2x, plus c.